Okay, I will now proceed to compound interest. Let us consider again the same amount, 1,000 pesos, and invested at 10% compounded monthly. So here, your 1,000 pesos at the end of the month will earn 10%. So we can say that we can write that the amount of money at the end of the first period will be 1,000 times 1.1. And at the end of the second period, this amount of money will earn another 10%. So we will multiply this amount of money again by another 1.1. So we get this by multiplying another 1.1, so we get 1.1 square. And at the end of the third month, this amount of money again will be multiplied by a factor of 1.1 because it is going to earn another 10%. So we will have 1,000 times 1.1 cubed. And of course, on the fourth month, we have that value. On the fifth month, we have that value. And on the sixth month, we will have that value. So at the end of the sixth month, our amount of money will be equal to 1,772. And our formula, we can now generalize from our observation that our formula for the future amount of money invested at a compounding interest will be equal to the principal amount times 1 plus I. Multiplying itself by 1 plus I n times, where n is the number of periods, we have this formula. We can also calculate for the equivalent present worth. Well, the formula here is called the future worth of P. We may also wish to determine the present worth of 1,772 by rearranging the formula. So our formula for the present worth will be equal to f over n divided by 1 plus I raised to the power of n. For example, you're expecting to pay 1,772 pesos at the end of the 6 months. How much money would you deposit in a bank, offering 10% interest rate monthly, so that you can withdraw 1,772 at the end of the 6 months? An amount of money enough to pay for your debt. Of course, you can substitute that to this formula here or using this rearranged formula. Okay, let us consider this problem. How long will it take money to double itself if invested at 5% compounded annually? So here is our formula for the compounding interest, the future worth of a compounding interest. So we'll have our f is to be doubled, meaning, our p is to be doubled. So our f is twice of p. So substitute that to our formula. So we'll have 2p equals p times 1 plus I raised to n. We can eliminate the p on both sides. And then we can substitute our I here. So we'll have 2 equals 1.05 raised to the power of n. So calculating your n using your calculator. So n is equal to 4.2 years. You may observe also that calculating for the value of n using the shift-solve function of the calculator actually takes longer. You can actually calculate the number of years a certain amount of money will double using 72 rule. 72 rule is a rule used to calculate the number of periods a certain amount of money will double given an interest. That is, to calculate the number of years, here the number of period that our money will double, what we need to do is only divide the 72 by the interest. So that is 72 and our interest is 5%. So we simply write here 5 and then calculate our n. So approximately our result here calculated using the calculator and using the 72 rule is close or are close.